G'day and welcome to a special edition of the Off-Chain Podcast. Don here with you, and it's special because it's part 2 of a conversation with Dr. Avi Loeb. Last time we caught up, he was telling us all about his upcoming trip to the Pacific Ocean, just off Manus Island outside of Papua New Guinea, where about 10 years ago, an intergalactic object passed through the Earth's atmosphere, leaving some debris which he hoped to find. And he went on that expedition just a couple of weeks ago, found what he was looking for. And so we want to find out today exactly what did he find? How did he find it? What does it look like? Is it what he was hoping to find? And if so, what does it mean? So please enjoy this special edition of the Off-Chain Podcast, part 2 of our conversation with Dr. Avi Loeb. Since we spoke with Dr. Avi Loeb about an upcoming expedition that he was about to go on, he's actually been on that expedition. And so we contacted Avi and said, please, would you come back, fill us in so that we don't leave people kind of sitting in suspense, finding out what's going on, through other means, because, we just spoke about it. And so we're keen to find out what's going on. So Avi, thank you so much for coming back on the Off-Chain Podcast today. You've been on this expedition. Tell me, how was this expedition overall? Was it as you'd expected? Did it go to plan? Tell us a bit about it.
Well, it was the most amazing 2 weeks of my scientific career. We went to the Pacific Ocean to retrieve any materials from the first recognized interstellar meteor that exploded there about almost a decade ago on January 8th, 2014. What was special about it is that it moved very fast, so fast that it wasn't bound to the sun. And it came from interstellar space. It was moving at 60 kilometers per second relative to the local standard of rest of the Milky Way galaxy. That's faster than 95% of all stars in the vicinity of the sun. And moreover, it was tougher than all space rocks that were cataloged by NASA over the past decade, 272 of them. So that raised the possibility that maybe it is a Voyager meteor. That's what I call a meteor that was manufactured technologically by another civilization. Just imagine Voyager, the one that we sent to interstellar space, colliding with another planet in a few billion years. It will appear as a meteor, but moving faster than usual and having material strength tougher than a rock. And we went there to figure out if we can find the materials and then examine them. And so the amazing thing is we found it. We found the droplets molten off the surface of this object on the ocean floor about 2 kilometers deep. And these were less than a millimeter in size, these what we call spherules. They are like metallic marbles. On the ship, we identified 50 of them. By now, as of today, I have an undergraduate summer intern, and she found 250 of them, these spherules, metallic marbles. Altogether, with a few other people finding more, we have now the count at 420. So a lot of these tiny metallic marbles. Let me show you a vial of the kind of materials that we found. This is from a FedEx delivery that I had a week ago with the materials. What we usually found, we basically used a magnetic sled, a sled that we dragged on the ocean floor with magnets on both sides, and it attracted magnetic particles. Most of them were just volcanic ash, black powder that you can see in this vial. But once we filtered out the tiny volcanic particles that were less than a quarter of a millimeter in size, we were left with other particles. And when we put them under the microscope, we found those metallic marbles that look really beautiful. In fact, we imaged one just a few days ago here at Harvard. It looks like a soccer ball, very fitting for the Women's World Cup.
Avi, that seems like a really crazy thing to think. Like, let's go in the middle of nowhere, 2 kilometers down, and find tiny, a few millimeter, across radius.
Less than a millimeter.
Less than a millimeter. How do you how do you start such an expedition? And like, tell me about this magnet that you were using. How does that work?
Yeah.
How could you have confidence of finding these things?
So it was an impossible task. If you would have asked me before the mission, before we went there, I was really worried we will not find anything, because the region was 10 kilometers on a side, roughly the size of a big city, and the ocean was 2 kilometers deep. And just think about it, finding a fraction of a millimeter type particles on the bottom of the ocean. That sounds hopeless. And, the meteor perhaps spread around tens of thousands of those, that's all, and over a 10-kilometer sized region. Now, the first thing was to localize the meteor path better than the US government did. They used satellites and ground-based sensors, and they gave us a 10-kilometer by 10-kilometer. And by the way, the US Space Command also confirmed that the 99.999% that they agree with my and my students' assessment that this is indeed of interstellar origin, that this velocity of the object was too large to be bound to the sun. So we narrowed down the path of the meteor using seismometer data from Manus Island in Papua New Guinea. Basically, this seismometer recorded the boom, the sound wave from the explosion. And from the time delay, knowing the speed of sound, we could tell how far it was, the explosion, from that seismometer. So that actually narrowed the path of the meteor to within a kilometer. It was a strip. And we decided to rent or hire a ship that is Australian, actually, and was made of aluminum. It was called the Silver Star, which is very fitting for this expedition. And it had a large deck. And what we did is build a sled, 200 kilograms in mass and roughly a meter in width, that was connected to the ship with a cable. And the cable went 5 kilometers long. So the sled was way behind the ship. But we basically tried to drag it on the ocean floor and just skim the surface of the floor of the ocean. And at first there was a challenge, because the cable would lift it above the ocean floor and it would behave like a kite floating. So it didn't touch the ocean floor, but then we realized we need to go with the current. And the engineers, we had an exceptional team of experts. I had to put them together. Of course, these are the best people in the world for ocean expeditions that I brought together for this expedition. We had about 28 people all together, including a filming crew. I had 50 requests from film producers and directors.
Wow.
To come on board, and I selected one such filming crew. And so first of all, the challenge was to assemble the group together, and then to design the sled, and then to get it on the ocean floor. It took us a couple of days to do that. And once we did that, we started collecting these materials, and most of it was volcanic ash. But when we saw the metallic marbles, through a microscope, then we knew that we are doing the right thing. It's just like finding an ant in the kitchen. Once you find a single ant, you know that there must be many more out there. And soon enough, within a few hours, we found many more such spherules. And so, just to explain the mechanism, we put the sled on the floor, 1 meter in size. We dragged it along a line of 10 kilometers at a time, and we had 26 such lines. And every time, after 8 hours or so, after we finish a line of 10 kilometers, we would bring it on the deck of the ship and scrape the magnets, basically get all the magnetic particles that are attached to the magnets into vials, and then dry them up, and then use a mesh to filter out the black ash. So all the tiny particles would go out, and we will be left with particles bigger than typically a quarter of a millimeter. And Then we put it under a microscope with a digital image, and we could see those metallic marbles and take them out with tweezers. And so the undergraduate student, Sophie Bergstrom, that works with me this summer, she did it now at Harvard. Just going through the materials, she found 250 of those spherules, and altogether we have 420.
That's amazing. I mean, the way you describe that actually sounds more like a Hollywood blockbuster, wanting to understand something interstellar, so we've got to go to the bottom of the ocean and
I should tell you,
world's greatest engineers together.
I should tell you, this filming crew, they have a large budget for a documentary. Hopefully it will come out in a year and a half. But one morning, I jog every morning at sunrise, and I did it also on the boat. And one morning they started filming me, and they asked me to continue jogging, so I jogged for 9 miles that morning, on my workout app. But they asked me at the end, the director asked me, it looks like you're running. Are you running away from something or towards something? And I told him, I'm running away from some of my colleagues who have very strong opinions without seeking any evidence. And I'm running towards a higher intelligence in interstellar space. And I can elaborate on the colleagues if you want.
Well, we don't really need to go there, but only to say, what are you hoping to find? So, you found the things that you were hoping to discover or find. What are you hoping that they tell you?
Right. So the first thing we are trying to find is whether the materials, of this meteor, basically it's the spherules that we believe were the molten droplets from the surface of the object when it was immersed, exposed to the huge amount of heat from the fireball. The fireball around it, as a result of its friction with air, as it came through the atmosphere at 45 kilometers per second, that fireball carried a few percent of the Hiroshima atomic bomb energy deposited into 500 kilograms. So you can imagine that a lot of molten material was generated, and we hope that some of the spherules that we have are indeed from the object. So the first thing we want to check is whether the composition is indeed different from solar system materials. And you can demonstrate that in two ways. One, by measuring the abundance of elements in those spherules and seeing that they are not the same as you find in solar system materials. But an even more elegant way is to look at radioactive isotopes. The solar system was formed out of a gas cloud nearby that had very well-defined ratios of isotopes. These are elements that are that have a half-life. They decay after a time. And the solar system, we know exactly the composition to a very good precision, and we can see if some of the spherules have isotope ratios that are quite different from the solar system because they were born in a different environment. We can even infer the age of the material from those isotopes that decay over the duration of the journey of this object. And we can tell if the age is different than the age of the solar system. For example, uranium-238 has a life span or a half-life very similar to the solar system age. So it's a very useful clock that we can use to date the age of the material. So we can tell. There are many. We can also tell by the morphology of these spherules whether they resemble solar system meteorites or not. And so I should say that on the day that we came back to the US, we went to UC Berkeley and did some preliminary analysis of a few spherules. And we found that the ones along the meteor path were very interesting. They had a structure of spheres inside spheres, just like Russian dolls. We found tiny spheres the size of a few hundred atoms, looking like eggs that are embedded in a background support mesh. So that you had these tiny spheres that probably condensed first. They solidified at first because they were tiny, and then they were engulfed with molten iron that glued them together. and then a bigger sphere had a few of those intermediate spheres. So you had spheres inside spheres, which was a beautiful sight for us looking at the electron microscope. I should say this opens a new frontier in astronomy of learning what's outside the solar system. We are using microscopes instead of telescopes. Traditionally, astronomy was about using telescopes to find out what's outside, but we are now doing something very different. And it's also the first time that humans put their hands on materials from a big object, bigger than half a meter, that came from outside the solar system. It's historic in that sense. And the first thing we want to demonstrate is indeed that the material is different from solar system material. The second task is to see if we can find evidence for it being technological in origin. Just imagine the Voyager spacecraft the surface of Voyager being molten as a result of the fireball around it as it collides with another planet. Obviously, the droplets that would result from that, the spherules, would have a different composition, some alloy of materials that nature doesn't put together. You can imagine molten computer screens, molten semiconductors. They would have an abundance of rare elements that is very different from rocks.
Yeah, and that's going to be, obviously in the first one, the identification part, is that enough in terms of, like you're talking about, those colleagues or naysayers, is that enough to be able to say, okay, well, this is the thing we're looking for? Or is it necessarily that second part you're talking about, the not just identifying it as being interstellar, but also something that perhaps even looks technological?
No, I think it's sufficient. Okay, for this to be a historic discovery, it's sufficient that we demonstrate the materials are from another place beyond the solar system, because it's the first time that we identified an object from outside the solar system and analyzed it. It's just like going to your backyard and finding something that came from the street. It doesn't look like the rocks that you're familiar with in your backyard. And if it looks like a tennis ball that was thrown by a neighbor, you get the benefit of learning that you have neighbors. So that's, of course, a bonus that would be even more dramatic. And the amazing thing is I have the materials. Now, speaking about my colleagues, on the day that I came back, well, first of all, before I went there were people saying, oh, you will not find anything. It's a waste of time. It's a waste of money. Why would you do that? And I said, look, I'm not asking you to do anything. You just sit back and relax. I'm doing the heavy lifting. If I come back with nothing, you tell me you didn't expect me to bring anything. Why is this negativity? I'm not taking any money out of your research to explore the nature of dark matter, for example. By the way, the dark matter is another example where we know that 83% of the matter in the universe is of a type of a substance that we don't find in the solar system. So how can we be arrogant and say, oh, everything in the sky must be stones, the same as we saw in our backyard in the solar system? No, if you have things coming from outside the solar system, they may be different. We know that most of the matter in the universe is different than you find in the solar system. So let's be open-minded about that, because this meteor was different than rocks that we found in the solar system, in material strength, in speed, and so forth. So anyway, I went there, and on the day I came back, there was a paper published in the Astrophysical Journal, meaning that not only the authors agreed with the premise of this paper, but also the reviewers. And this paper was saying, we cannot fit the data about this meteor using our model for stones, for stony meteorites from the solar system. Therefore, the data must be wrong. So this object was not moving at the speed that the US government claimed. It actually is 3 times slower. It's from the solar system, and it cannot be made of iron. That's what they said. And when the paper came out, I held in my hands the materials, the spherules, from the site of this meteor. Okay, and we also examined their composition with an X-ray fluorescence analyzer on the ship. And we realized that most of the composition is iron. So I asked you, why would anyone make a statement on materials that we retrieved after a lot of effort without them having access to the material, knowing what it is. And even after I came back, there are lots of bloggers and scientists who say, oh no, this is nothing. So at first they said, you will not find anything. When I came back, they said, you didn't find anything. Well, who are they to say that? I have the materials. We're now going through it with the best instruments in the world. We have 3 laboratories that are studying these materials. One is in UC Berkeley. The bulk of the materials are at Harvard University. We are working together with the University of Technology in Papua New Guinea. I have a visitor, Dr. Jim Lam, that came all the way from Papua New Guinea. He's now visiting me this week, participating in the analysis that we are doing at Harvard University. And then the Bruker Corporation in Berlin, Germany, they have access to the best X-ray fluorescence analyzers. And I send them a little bit of material as well. So I gave the materials to the experts, the best people in the world, because it's a science project, so we share materials, we share knowledge, but we have the possession, we are doing the analysis, yet other people express very, they're very convinced, they express very strong opinions about the nature of these materials. And it shows you, these people are calling themselves scientists, but they are not waiting for the evidence to come out before expressing an opinion. I think it's a betrayal of the definition of their profession. How can they express an opinion on something they don't have access to, and that we did not even analyze yet? So it shows you that they are not seeking evidence in expressing opinions. That is completely contradictory to the way science should be done. Science should be done by being guided by evidence, by data, which is what we are doing. We collected the materials. We're now going through the materials with the best instruments in the world. And these scientists are dismissing the significance of these findings without having access to the materials.
Yeah, just a prior commitment to their already held understanding, obviously, is what's going on there.
Right. I think it comes from 2 directions. One, that these are experts that base their stature on past knowledge. Okay. But so then they want to maintain their stature by basically insisting that anything we find must be consistent with their past knowledge. That's just like saying the data must be wrong because it doesn't agree with our model. Okay. But the only way for us to learn something new is by the data not agreeing with our models. So you should allow yourself to revise your models. That's the only way to learn something new. We learn about quantum mechanics without anyone expecting it to exist. We learn about dark matter without anyone expecting it to exist. If people were to insist that that the data must be wrong, that there cannot be anything beyond the matter that we have in the solar system, then most of cosmology nowadays would not exist. I mean, most of cosmology is focused on trying to understand the nature of dark matter. So the only way for us to learn something new in science is, first of all, to respect data that doesn't agree with your model. So it's not about being arrogant and pretending to know everything. It's a learning experience. Be modest. Don't pretend that you are the expert that knows the answer in advance. And the second is to be guided by the data and try to figure out what it means by collecting more data. That's the scientific process. And I'm sorry to say that, but we often complain about politicians that do not adhere to evidence. But here are scientists that are not even seeking evidence. They don't even want to wait until they see the evidence before expressing a very strong opinion about it.
On that, you've recently written a book, published a book called Interstellar. And after publishing the book, you have in your hands potentially interstellar material. How are you expecting your book, the things that you've presented in your book, to be confirmed or challenged by your latest discovery? What does that look like?
Well, it really depends on what we find. if we find the material to be of interstellar origin, then of course it's a demonstration that the entire research path that I took was fruitful, was the correct thing to do. And it would constitute the first time that humans put their hands on the materials from a large object from outside the solar system. And, this material was delivered by FedEx to my doorstep within a few days, but I realized it took it potentially millions or even billions of years to arrive to the Earth. And it's a completely different method of learning what's outside the solar system. You can look through the windows of your home, you can use a telescope, but it's a very different feeling, it's a very different experience to actually hold something in your hand when you go out to your backyard. And one thing to realize is, that this could have been sent by a civilization that is dead by now. Because if it took, billions of years for it to arrive to us, maybe the star extinguished life on the planet that this civilization formed on. And in that case, you can think of the meteor fireball, if indeed it's a technological gadget that created that fireball, you can think of it as a memorial candle to commemorate that civilization that is not with us anymore. Because everything in life is transient. You have to enjoy it while it lasts. And, we on this planet, within a billion years, we will not be able to sustain life as we know it, because the sun will boil off all oceans on Earth within a billion years. Irrespective of what we do, there will be no liquid water on the surface of Earth. And, most of the stars formed billions of years before the sun. And if you just imagine those civilizations that may have existed on habitable planets like the Earth around them, they may have been extinguished by now. So the only memorabilia left from them are these gadgets that they send to interstellar space. And, it always reminds me of the fact that when my mother passed away 4.5 years ago, I went back to see my childhood home, which was by then sold to strangers. And when I got there, the house was unrecognizable. It was renovated. The environment, the street was noisier than I remembered it. The chicken house, the coop that I used to collect eggs every afternoon in as a child, was not there. And it basically taught me an important lesson that, when you go through life, to maintain a stable posture, you really need to move forward, because everything changes. It's just like riding bicycle. If you don't move forward, you will fall off. And because, there is only a rubble of memories after a long enough time. There is nothing left. And the same would be true of Earth. The same may be true of other planets where civilizations were extinguished billions of years ago. We were not witnessing that because we were not around at that time. Humans started to exist only over the past few million years. That's one part in 10,000 of the age of the universe. We didn't witness most of this history, but we can find traces of those civilizations by, any space trash that they left behind. Just like plastics in the ocean, you can find them accumulating over time. These gadgets, if they are launched by chemical propulsion, like our spacecraft, they cannot escape the gravitational pull of the Milky Way galaxy. They will stay bound and they keep accumulating like plastics in the ocean. And so all we need to do is check around whether interstellar objects represent technological civilizations or not. And, we haven't done that. And only over the past decade, we found the first 4 interstellar objects. These were 2 meteors, one that I described, another meteor from March 2017, Oumuamua, which was the subject of my book, Extraterrestrial, a very unusual object the size of a football field that had a shape that is most likely flat based on the variation of reflected sunlight from it. And it was pushed away from the sun by some mysterious force without showing any cometary evaporation, no rocket effect. So the first 3 really looked unusual relative to asteroids or comets that we are familiar with, because the meteors, for example, had material strength so high that made them outliers relative to space rocks. The fourth interstellar object was just usual. It was a comet. It was the name was Borisov. So that's an example where you do get some familiar things coming from the street, cosmic street, into your backyard. But the first three were weird. And I say, that it should trigger our curiosity. We should look, into their nature. And that's exactly what we did in this expedition.
Well, certainly people's curiosity has been piqued more recently, especially with, like you talk about space junk in your words there. I've had a few whistleblowers coming out in the US recently making some pretty wild claims, even before Congress. Do you have an opinion about the disclosure movement, where you see the direction going, the credibility of the people making claims, those kinds of things? If a piece of space technology has come from somewhere a billion years ago and that civilization no longer exists, it's markedly different to that civilization is coming here and making contact in some degree.
Well, the way I think of it is not as living creatures coming here, but more like technological gadgets with maybe, if they're functional, with artificial intelligence. But in terms of the reports from government, I haven't seen convincing evidence as of yet. And even the David Grush story, and there will be hearing in the U.S. House of Representatives in a couple of days, hearings from David Grush himself and two pilots about their what they know. And David Grush basically said that the U.S. government is in possession of materials from a crash site or crash sites of technological gadgets from other civilizations. And the thing is that he did not witness those materials. He just heard people talk about them and saw documents. As far as I'm concerned, I'm a scientist. If people don't show me evidence, I cannot make any sense out of it. Because people can say anything. Other people in government could have tricked him for some reason. Who knows? Until you see the actual evidence, you cannot make any sense of it. So I would remain agnostic about, what it represents. I don't know. I mean, it's interesting. If it's true, then it would be amazing to see those things that the U.S. government has. And I should also say that they should not be held in confidence. They should not be classified, because anything that comes from interstellar space, does not care about national borders. It has nothing to do with national security. Someone coming from, thousands of light years away would not care about how we split the land on this tiny rock that we call Earth, orbiting around the sun, that was left over from the formation of the sun. Like, this is ridiculous to imagine this being a matter of national pride or national interest. It should be information shared by all humans, just like science is. And I hope that if the US government has anything, they would release it so scientists can look into them. And I will be delighted to look into any materials or information that the US government has. So I'm intrigued by the reports. It's interesting there are people from government talking about it. But as long as it's just people talking about it, that doesn't carry enough evidence for me.
Yeah, I'm not sure the game theory checks out on the US government sharing secrets like that might have, military or economic advantages in tow. I'm a bit skeptical about
so
that.
that's the question. It really depends on what they have. And I haven't seen anything unusual, unearthly being represented in the battlefield. So I don't know if there is, it's being used for if it exists, if it's used for anything. Economically, again, all I see are technologies that are following each other. I don't see a quantum leap in our abilities that resulted from some unknown source. So I would be skeptical. Also, the government is not the best organization to handle such things and interpret them. It should be
Agreed.
done by scientists. It should be done by scientists.
Yeah, absolutely agree on that one. You mentioned funding earlier, and I've seen reports that your latest expedition was significantly or wholly funded by Charles Hoskinson from, at least in our circles, Cardano fame. What is the common interest between you and Charles, or how did you connect? How did that come about?
Oh, it was very simple. I announced the expedition as soon as the US government provided data that basically at the 99.999% confidence confirms the assessment that this object was interstellar. And they gave us information about the fireball and so forth. And we used it to plan the expedition. And at that point, I basically announced it. I had more than 3,000 interviews over the past 2 years. And I started talking about this expedition that we plan to have and that we need funding at $1.5 million for. And I just got an email from Charles Hoskinson's assistant, and they arranged for a Zoom call, and I had that meeting with them, and they said, and Charles said, "You have the money." Very simple.
Wow.
He was. I should say. I also, we went with his private jet through Australia to the Pacific Ocean, and I had a long time to chat with him during the flight. And he is genuinely interested in the science associated with this expedition. He was on the ship. He helped us scrape the magnets and get all the materials. And he really cared about the science and supported it in a very generous way. So I think it's genuine. I think he is really curious and interested in what we are doing. And that's what drove him to contact me in the first place.
That's really cool. Actually, that's very cool. Charles, come on the show. Tell us your side of the story as well. I'd love to hear about it. Avi, in wrapping up, what is next? Like, assuming this goes really well, do you have plans for a future expedition? Are there plans for what comes next after this?
Right. So these spherules, you can also think of them as romantic rose petals that lead you to your partner. In a sense that if there is a big piece of the meteorite or of this object, we now know where to look for it. It will require a different set of instruments, for example, a sonar that will image the ocean floor with high enough resolution. And the point is, if you find a big piece of the object, you can easily tell the difference between a rock and a technological gadget, because the gadget would have a label made on exoplanet Y, or it would have buttons on it. And I actually asked my students at the last class of the spring semester, I said, if we find a gadget, technological gadget, and it has buttons on it, should we press a button? And half of them said, no way, we are worried about the consequences to humanity. And the other half said, of course, you should press a button because we are very curious to learn what will happen. And then one student asked me, what would you do, Professor Loeb? And I said, I will take it to a laboratory and examine it before engaging with it. And, that would be the one possible future expedition. And obviously it depends on what we find in the study of the spherules. But the second possibility is to go after the second interstellar meteor, which was closer to Europe, actually. So we might do that depending on how the spheral analysis goes. And so we have two options.
All right. And if someone wants to find out more about what you're doing and what you're discovering, or even reading your book, how can they do those things?
Right. So I have a new book coming out in August 2023. It's called Interstellar. So in it, I discuss the implications to humanity from the kind of research that I'm doing for the future of humanity. Otherwise, I have essays on medium.com. So if you type on Google Avi Loeb, AVILOEB, at medium.com, you will find my essays, and I give there regular reports and updates about the results from the analysis of the spherules.
Okay, awesome. Thank you so much for coming on the show today, and thank you for coming on the show a few weeks back as well. We really, really appreciate it, man. You've given us a lot to think about. Really appreciate your time, and all the best with your learnings and current, looking into the spherules that you found and future expeditions as well. Looking forward to hearing about those as well. Good on you.
Thank you so much. I will be glad to appear again once we know the answer.
Thank you. Appreciate it.
Bye-bye.
Thanks for joining us today. Hope you've enjoyed this episode of the Off-Chain Podcast with our special guest today, Dr. Avi Loeb. Wonderful to hear about his recent trip to just off Manus Island, finding this intergalactic object. And man, I'm really looking forward to finding out what he finds out, what secrets it might hold, if any. And I'm sure we'll have him on the podcast again really soon. As always, please like, subscribe, or even better yet, share a portion or all of this episode that you found helpful with a friend. And join us again next week for another great episode of the Off-Chain Podcast. Till then, take care.